scientists, Caroline here. In our last lesson, we discovered how human impact on the environment has changed over time. Today, it's estimated that there are over 8 billion people on planet Earth sharing the same resources and interacting with the environment. And the number of people on Earth is going up every day. In fact, by the time this video is over 11,000 new people will have been added to the world's population. What does that mean for our environment, our resources, and our future? Today we'll learn about population growth for humans and for other living organisms. We'll investigate what types of factors allow for continued growth, what resources set a cap on population growth, and how human population growth impacts our environment. Are you ready, scientists? Let's get started. In Environmental Science 1, we learned about the different levels of ecological organization: individual, population, community, ecosystem, biome, and biosphere. Today, we'll focus on populations. Do you remember the ecology definition of a population? A population is all the members of the same species that live in the same area, share and compete for resources, and reproduce with one another. For example, let's say we wanted to look at a population of white-tailed deer. We aren't talking about all of the white-tailed deer in the world. A population of white-tailed deer is all of the deer that live in the same woods, eat the same plants, share space, and could mate with one another. Populations can change. When members move away or die, they get smaller. And when new members are born or move into the area from somewhere else, the population gets bigger or grows. Scientists often use graphs as a tool to track populations over time. Let's take a look at this graph together. What trend do you notice? Pause the video here to record your thoughts. This population is growing quickly. In fact, the population appears to be rising in a straight line toward the sky. When a population grows like this, it's called exponential population growth. Exponential growth looks like a J-shaped curve because the population numbers keep going up forever. In other words, this type of growth curve shows a population in ideal conditions. No diseases or natural disasters wiping out members of the population, few predators, and infinite resources to share. Bacteria in a controlled lab setting can sometimes show this type of exponential growth, but most populations in the real world can't grow forever. Why? It all depends on resources. Let's take a look at a different population growth curve. What do you notice about the shape of this curve? At first, it looks like exponential growth, but eventually the population stops growing rapidly and the curve starts to bend and flatten. This is called logistic population growth. This type of growth looks like an S-shaped curve, and it shows a population leveling off. But why does this happen? Let's go back to our population of white-tailed deer for a moment. What would stop this population from getting bigger and bigger forever? Pause the video here to record your thoughts. These deer probably don't live in a perfect forest with no predators and endless food, water, space, and potential mates. Eventually, a real forest would run out of the resources needed to keep supporting more deer. Some deer may not get enough to eat. Others might get pushed out of the area. As the number of deer increases, competition increases too, and the population levels off. That leveling off is called carrying capacity, the maximum number of individuals the environment can comfortably support over time. The carrying capacity is set by a limiting resource in the environment. In other words, the resource that is least abundant limits the size the population can grow to. Most real populations show logistic growth. When there aren't enough resources to support more individuals, population growth slows down. Ecosystems simply can't support unlimited growth. But limiting resources are different in each ecosystem and can change based on events. For example, if a drought reduces available water in the hydrosphere, the carrying capacity for the deer might decrease. Or if humans plant more trees in a nearby nature preserve, there might be more food and shelter in the biosphere, so the carrying capacity could increase. Both exponential and logistic population growth curves have periods of time with rapid growth in the population. It's got me wondering, if human populations are growing quickly, which type of growth is this? Just like in deer or bacteria populations, a human population refers to a group of humans sharing resources in the same space. Sometimes a population might refer to the number of people in one specific town, state, or country. But thanks to technology, humans can share resources around the globe, so we call all of the humans on Earth a world population. Our population has grown rapidly over the last few centuries, especially since the Industrial Revolution. But do you think this trend can continue forever? Which type of growth do you think our human population has? Logistic or exponential? Pause the video here and record your thoughts. We're in a period of rapid growth now, but remember, Earth is a closed system. Eventually, we will run out of some key resources, and then our population will level off. That means that our human population has logistic growth, and there are limiting factors that could set a carrying capacity in the future. This is why it's so important to pay attention to the resources we're using today. If we use them sustainably, making sure we're only using what we need, we'll have more resources for population growth in the future. Throughout this course, we'll learn about the resources our human population depends on, how we can use these resources responsibly, and how to access these resources without damaging our environment. As we went through the lesson today, we learned about population growth. Under perfect conditions, populations of living things can show limitless exponential growth, but these perfect conditions rarely exist in nature. Most of the time, population growth is impacted by resource availability. In order for populations to grow, they need to have enough food, water, and shelter to support new members. This is called logistic growth, and this is the type of population growth we see in most populations on Earth, including humans. In our next lesson, we'll take a closer look at the resources that support the human population, the ones we depend on every day, the ones that could limit our growth in the future, and how we can make sure they're shared fairly and used responsibly. Until next time, remember, when humans interact with the Earth, our actions can have big impacts, good and bad. As human populations grow, so do our impacts. Keep asking questions and keep thinking like a scientist. I'll see you next time.